What would happen if all the ice in Antarctica melted? Antarctica, the land covered in ice and snow at the southernmost tip of the Earth, is not only cold but also extremely vast. Few people know that Antarctica is the fifth largest continent in the world with an area of up to 14.2 million kilometres, far exceeding the United States and nearly twice the area of Australia. But what is really impressive is under that white ice layer, Antarctica is holding nearly 90% of the ice on Earth. The ice layer covering Antarctica has an average thickness of about 2,000 meters, but in many places this thickness can be up to more than 4,000 meters, almost as high as the Alps. When converting all this ice into volume, the number obtained is about 18.4 million kilometers, equivalent to 75 times the total freshwater reserves of the world. To put this in perspective, if you cut this ice sheet into thin slices just 70 meters thick, you could create 6 layers of ice that would cover the entire surface of Antarctica. And all of it would be fresh water. What does this mean? If all that ice melted, it would not only turn Antarctica into a bare continent, but would also have a direct impact on global sea levels, ocean ecosystems, and even our planet's climate. But that's a story for another time. If all the ice in Antarctica melted, the consequences would be beyond imagination. According to the U.S. National Snow and Ice Data Center (NSIDC), this would cause global sea levels to rise by about 60 meters. That is enough to submerge hundreds of coastal cities around the world, from New York and Shanghai to Tokyo, Bangkok, and even Vietnam's Mekong Delta. Beyond infrastructure damage, this event would trigger a global migration. More than 1 billion people living in low-lying areas would be forced to leave their homes, becoming climate refugees. This would be an unprecedented humanitarian crisis in modern history, affecting global security, economics, and politics. In addition, rising sea levels would cause saltwater intrusion deep inland, destroying agriculture and freshwater sources. Rich deltas such as the Bengal Delta in India or the Nile Delta in Egypt will be severely threatened, causing massive food insecurity. Once densely populated areas could become ghost cities in a matter of decades. And these are just the initial impacts of melting ice. Impact on the ocean and global climate. As the massive Antarctic ice sheet melts, a dangerous consequence will occur just below the surface of the sea. The salinity of the seawater will drop dramatically. Antarctic ice is fresh water, so when it melts into the ocean, it will dilute the salt content. This is not simply a change in the flavor of the seawater. It can disrupt the entire design of the ocean circulation, which is based on differences in temperature and salinity. Previously, in the cold seas near the Antarctic and the North Atlantic, the high salinity and low temperature of the seawater made it heavier, sinking deep, creating a cold downstream current. This current pulls a warm countercurrent that spreads towards the equator and branches out to many places such as the Gulf of Mexico, the coast of Europe, etc. This is quite like a machine engine that regulates the global climate balance. If the seawater becomes too bland, this engine can turn off. And the consequences, the climate in Europe and the US can suddenly cool, causing unexpected harsh winters. In some areas, temperatures could drop, similar to local ice ages, causing severe disruption to ecosystems and agricultural production. Conversely, the release of CO2 and other greenhouse gases from melting permafrost could accelerate superwarming. Global average temperatures would rise more than previously predicted, causing extreme weather events such as hurricanes, droughts, and floods to skyrocket. In short, before we see Venice sink, the indirect effects of the ocean and climate, from ocean current imbalances to unusually cold spells or superwarming, will be enough to create a global climate crisis that affects families and countries. Can you imagine Antarctica as a bare ice plain? In fact, under the current 2-4 kilometer thick ice sheet, the terrain of Antarctica is very complex. Research in 2019 by Professor Marty at the University of California showed that Antarctica is actually a collection of interconnected continents and island systems, similar to Australia or the Indonesian archipelago. rather than the wet continent we think it is. The Transantarctic Mountains are clearly divided in the south, while the north is lower slopes and has many submerged islands. The most prominent of these is the Vinson Massif, the highest mountain in Antarctica, which was once covered by a thick layer of ice. When the ice melts, Vinson will be fully exposed, rising more than 4,892 meters above sea level, making it as majestic as the current Alps. And most of the terrain elsewhere, it is deep valleys and limestone plains buried by ice for millions of years. Some areas have mild seismicity and stratigraphic structures that once created oil and gas, precious minerals such as gold and diamonds, which can accumulate densely at the bottom. An extremely interesting point due to the phenomenon of isostatic rebound. When the ice disappears, the land will slowly rise, just like the scene in Finland after the last ice age. Therefore, the map of Antarctica, as we know it now, will be clearly deformed every decade, every century, with tens of meters of land rising above sea level. Even if this phenomenon occurs for tens of thousands of years, Antarctica will no longer be a motionless white ice field, but will become a new burning continent between two oceans with mountains, lakes, jagged peaks, and vast valleys. When the ice melts, the ground rises, the secret from the underground of Antarctica. One of the strange but little-known phenomena after the Antarctic ice melts is that the ground will slowly rise. It sounds strange, but this is a completely real process in geology called isostatic uplift, or in international terms, isostatic rebound. To understand this, imagine you put a thick, heavy dictionary on a rubber cushion. While placing the book, the cushion sinks, but when you lift the book off, the cushion surface will slowly return to its original shape. Similarly, the ice layer in Antarctica has a huge weight, estimated to weigh millions of billions of tons, that is compressing the Earth's crust below. Over millions of years, the gravity of the ice layer has caused the ground to sink even hundreds of meters below its original equilibrium position. When the ice melts, this enormous pressure is released. The Earth's crust, which has been compressed, will begin to recover, rising slowly, a process that may take thousands of years but is completely measurable. Many geophysical studies show that some areas in Antarctica are currently rising about 1-2 centimeters per year, even though the ice has only partially melted. If all the ice disappears, the rate of uplift could increase many times, changing the terrain of the entire region in the direction of rising above the sea level. This change is not only geometric, but also affects geographical maps and future planning. Areas that are currently deep below sea level, such as glacial valleys or underground lakes, could become plateaus, while plains would rise to form new coastal islands or plateaus. From a geological perspective, Antarctica could transform from an icy continent into a completely new geographical ecosystem, including many large and small islands, deep lakes, hills, and rivers. This phenomenon has occurred in Earth's history. After the last ice age about 10,000 years ago, many areas of land in Finland, Sweden, and Canada that were once covered by ice gradually rose after the ice melted. In Finland, the phenomenon of land uplift is still ongoing, and the land is still rising about 7, 10, and 9 million years each year, creating new islands along the coast. This means that the map of Antarctica in the future may not look like it does now. New coastlines will form, mountain ranges currently covered by ice will be completely exposed, and may even form natural watersheds between climate zones. Not only that, land uplift can also affect earthquakes, volcanoes, and plate tectonics. When the pressure from the ice sheet suddenly drops, the imbalance of geological forces can trigger tectonic shifts, increasing the risk of fracturing, magma eruptions, and other seismic events, which were previously compressed by the weight of the ice for millions of years. As the ice melts, minerals emerge. Resource fever in Antarctica. Deep beneath the icy waters of Antarctica lies a great secret that the world is gradually turning its eyes to: enormous mineral resources. For millions of years, Antarctica has been largely untouched by human intervention, but that does not mean it is without value. On the contrary, When the ice melts, this continent could become a new resource hotspot for humanity, a gold rush of the 21st century. Scientists have found evidence that hundreds of millions of years ago, Antarctica was part of the supercontinent Gondwana, which includes Africa, South America, India, and Australia today. Places that were once connected to Antarctica, such as South Africa and Australia, are rich in minerals such as gold, diamonds, uranium oil, and natural gas. Therefore, it is very likely that similar valuable mineral deposits exist underground in Antarctica, just hidden behind kilometers of ice. It is no coincidence that many developed countries have established permanent scientific research stations in Antarctica. Although nominally for scientific purposes, it is undeniable that this is also a way to establish geopolitical influence and the right to exploit potential resources in the future. In research documents, many areas in West Antarctica are said to have reserves of coal, iron, copper, zinc, nickel, and especially rare earths, extremely important materials for high technology such as batteries, magnets, electronics, and defense equipment. In addition, the continental shelf area around Antarctica is also likely to contain oil and natural gas, similar to the large oil fields off the coast of Norway or Russia. According to some preliminary estimates, the oil and gas reserves in this area could be enough to supply energy for the whole world for decades, if exploited effectively. However, the exploitation of resources in Antarctica is still limited by the Antarctic Treaty signed in 1959, which stipulates that the continent is a demilitarized zone serving only peaceful purposes and scientific research. However, this treaty is effective indefinitely, but not forever. That is, it can be amended or terminated if the member countries agree. With increasing pressure from the energy crisis, resource depletion, and geopolitical competition, it is not impossible that the treaty will be challenged in the future. The worrying thing is that if one day major countries open the flag for resource exploitation in Antarctica, the consequences will not only be environmental changes, but also lead to conflicts over ownership, disputes over exploitation areas, and severe impacts on the extremely sensitive ecosystem here. As the ice melts, pathogens emerge, an invisible threat from the past. When we think of the consequences of melting ice in Antarctica, we often think of rising sea levels, climate change, or resource exploitation. But there is a potential risk rarely mentioned but could cause a global catastrophe: the reemergence of ancient viruses and bacteria frozen for tens of thousands of years. Antarctica is considered one of the world's largest permafrost regions and is also a natural biological graveyard, preserving traces of ancient organisms from the Ice Age. Many organisms, bacteria, and even viruses have been trapped in the deep ice where the temperature is always below 0 degrees Celsius. The environment is almost oxygen-free, light-free, and does not decompose. This is the ideal condition for preserving genetic material, including pathogens that existed tens of thousands, even hundreds of thousands of years ago. As the ice melts, the permafrost will break down, potentially releasing viruses, bacteria, fungi, and other microscopic organisms that have never been exposed to the modern world. The danger is that our immune systems are unprepared for these prehistoric pathogens, and there are no vaccines or treatments available. The result could be the emergence of new pandemics that are more dangerous and difficult to control than any we have ever seen. In fact, this is no longer a theory. In 2016, in Siberia, where the freezing conditions are similar to Antarctica, an unusual heat wave thawed the deep ice, exposing the carcass of a reindeer that had died decades earlier. The carcass carried the bacterium Bacillus anthracis, the agent that causes anthrax. The result: more than 2,300 reindeer died and dozens of people were infected. That's just a small taste of what could happen if the entire Antarctica, home to even more ancient creatures, were to awaken. In addition, a 2015 study from Ohio University found 28 previously unknown ancient viruses in ice samples taken from the Tibetan Plateau. This suggests that finding ancient viruses in Antarctica is entirely possible, and that these viruses may even have genetic makeups unlike any previously known, making them even more difficult to detect. What makes this threat even more frightening is its invisibility and unpredictability. Unlike rising sea levels, which can be measured, or climate change, which can be predicted, ancient viruses have no obvious signs until they explode. All it takes is a laboratory accident or an expedition accidentally coming into contact with an area containing ancient animal remains to awaken a previously unknown virus and spread it in the era of globalization. Current state of Antarctica. Antarctica loses an average of 690 billion tons of ice each year. A huge amount, but it happens almost silently. Satellite images and geophysical data over the past 20 years show that the rate of ice loss is not only continuing, but also accelerating faster than scientists previously predicted. In the past 6 years alone, an ice mass the size of Los Angeles has disappeared from the map. However, what is worrying is not just the amount of ice that has melted, but the self-accelerating mechanism of this process. As the surface of the ice thins and darkens, it absorbs more heat from sunlight, melting more ice underneath, creating a dangerous cycle. The more ice melts, the faster the melting process. In addition, warm water from the ocean penetrates under the ice, silently eroding it from below, making the surface appear stable, but the inside is weakening. Scientists warn that if humans do not take drastic action to curb greenhouse gas emissions, Antarctica could reach a point of no return. That is, even if we stopped all emissions today, the ice would continue to melt because it had already passed the natural equilibrium point. At that point, total melting would only be a matter of geological time, perhaps hundreds, thousands, or millions of years depending on the level of global warming. Looking further back millions of years, the prospect of a completely ice-free Antarctica is not entirely impossible. In the distant past, some 100 million years ago, Antarctica was a tropical rainforest home to dinosaurs, trees, and warm-blooded animals. Fossils have been found to prove it: petrified tree stumps, pollen, and even dinosaur footprints in the icy depths. This suggests that Antarctica was not always cold. If global warming continues, the continent could gradually return to its original form. No more ice and snow, but forests, rivers, mountains, and possibly new life forms. In the long term, if humans survive and have the technology to adapt to the harsh climate, Antarctica could be zoned as a new habitat, even a country of climate refugees in case other coastal areas become uninhabitable. However, the downside of this scenario is that the entire planet will pay a price. For Antarctica to return to an ice-free period, it would mean that other continents would have to endure severe changes: widespread desertification, intensified superstorms, the disruption of the global food chain, and large-scale ecological imbalances. Antarctica is changing, and the melting of its ice is not just a story for the polar region, but a warning for the entire planet. What we do today will determine the future of the Earth tomorrow. What about you? What do you think is the most dangerous thing if Antarctica completely melts? Leave a comment below to discuss together. Don't forget to like, share, and subscribe to the channel Cosmic Y so you don't miss the next fascinating scientific discoveries.